Hello, this is Dr. Ayeshola Ogundele, Astronautics for Exploit. Space resources utilization, the cornerstone of this space exploration. The focus points of my presentation are as follows: importance of space resources and utilization of space resources. Over the years, analysis of celestial objects, naturally occurring physical entities that exist in the observable universe, such as planetary systems, star clusters, nebulae, and galaxies, asteroids, moons, planets, comets, and stars, has shown that they are made up of abundant natural resources which are useful for various purposes. A rich diversity of raw materials present on the Mars, Moon, asteroids, and a host of others will enable actualization of deep sea exploration. Research findings show that the lunar rock and regolith surface material are rich in important and useful elements that will be beneficial to the humankind. The natural resources, when extracted and processed into useful form, will help in improving lunar economy. A better understanding of the potential for in situ resource utilization at the Moon is based on the insights and knowledge gained from the analysis of the lunar resources obtained through lunar missions. Availability of resources will be the main determining factor for the location of lunar bases and human permanent settlement on the Moon. Development of advanced technologies and innovations by the space agencies and private space companies will play key roles in mining, processing, and usage of the in situ resources and reduction in cost of bringing raw materials from the Earth. Several potential uses of space resources have been identified. For the power generation, space-based solar power, the concept of collecting solar power in outer space by solar power satellites and distributing it to Earth have been proposed. The possibility of extracting propellants from the Moon, Mars, asteroids, and a host of others has also been established. The extracted propellants will be useful for space transportation, and this will provide better access to deep space. Due to the cost of resupply and the impracticality of resupplying interplanetary missions, the prospect of growing food in flight is incredibly appealing. There is potential use of space resources for the provision and establishment of habitat for the astronauts. Importance of space resources. Presently, there is a high interest in the extraction and processing of space resources, as these will lead to wealth creation. According to research findings, mining of resources in outer space can be used to support missions to the Moon, Mars, and beyond. A deep space industries concept for a spacecraft that could retrieve space resources from the surface of an asteroid is shown in this picture. The astronomical objects such as the Moon, Mars, and asteroids are believed to have resources that could be mined, used in space, or brought back to the Earth for use. The recent discoveries of water ice on the Moon is attracting investors, space agencies, and private space companies to embark on space resource mining and manufacturing. The concept of mining of space on the Moon is shown in this picture. Advantages of space resources. Satellite refueling. The water found on the moon can be converted into fuel, and this will enable satellite refueling at lower cost, traveling to the Mars and beyond. Lunar settlements. Ice can be converted to water and oxygen for lunar settlements or operations. The lunar soil, which is referred to as regolith, can be used as construction materials. This picture shows demonstration of commercial use of lunar polar volatiles as in-space propellant. Utilization of space resources. There are various utilizations of abundant natural resources which is found in space, and some of them are power generation as propellants, solar cell production, space farming, space manufacturing, space habitat, radiation and thermal protection. Power generation. Sunlight is brighter outside the atmosphere and can shine all day. Space-based solar power is the concept of collecting solar power in outer space by solar power satellites and distributing it to Earth. Several proposals of space-based solar power generations have been put forward. This picture shows integrated symmetrical concentrator SPS concept. Space manufacturing using asteroids or lunar materials will help in the realization of the various solar power generation proposals using space resources. Space launch technologies. Radical new space launch technologies will fasten space manufacturing. This picture shows illustration of the solar power satellite by means of arbitrarily large phased array system. A future lunar-based settlement and continuous operation of resource mining and extraction companies will be successful with the availability of solar illumination for power generation. It was reported that there is uninterrupted illumination on the rim of some lunar pole craters. This is a good place for the location and powering of the lunar base, mining, and in-situ operations. This picture shows a concept and illustration of beaming solar power from space. Space-based solar power systems convert sunlight to some other form of energy, such as microwaves, which can be transmitted through the atmosphere to receivers on the Earth's surface. Usefulness of space-based solar power. It is attractive to those seeking landscape solutions to anthropogenic climate change or fossil fuel depletion. Demonstration of solar power generation is shown in this picture. Space-based solar power systems convert sunlight to some other form of energy, and it is very attractive for large-scale solutions. This picture shows artist's concept of the transmission of space-based solar power. Space resources can also be used as propellants. The possibility of extracting propellants from the moon, Mars, asteroids, and hosts of others have been established. The extracted propellants will be useful for space transportation, and these will provide better access to deep space. It was proposed that water could be heated in a nuclear or solar thermal rocket, which may be able to deliver a large mass from the moon to low Earth orbit. Illustration of fueling of SpaceX Falcon rocket for return trips from Mars back to Earth is shown in this picture. Propellants from the Earth. The use of space resources for making propellants will reduce the amount of propellant that must be lifted from Earth in considerable amount. The extracted propellants could be exported to the cislunar space, various Lagrangian points between the Earth and the Moon, and to geostationary Earth orbit and low Earth orbit. The propellants could be used to support refueling of reusable rocket up stages, orbiting satellites, lunar resupply operations, and missions to asteroids and Mars. A data 4 heavy during liftoff is shown in this picture. Aluminium, as well as other metals, has been proposed for use as rocket propellant made using lunar resources, and proposals include reacting the aluminium with water, extracted propellant. It was proposed that methane propellant can be manufactured on the Mars via the Sabatier process. SpaceX suggested building a propellant plant on Mars that will use the Sabatier process to produce methane and liquid oxygen from subsurface water ice and atmosphere. Artist illustration of SpaceX Starship vehicles on the surface of Mars is shown in this picture. Space farming. This is another utilization of space resources. Space farming refers to the cultivation of crops for food and other materials in space or on off-Earth celestial objects. A sample of this is agriculture on the Moon. Farming on celestial bodies, such as the Moon or Mars, shares many similarities with farming on a space station or space colony. A suctioning plant floating freely in the International Space Station Destiny Laboratory is shown in this picture. Due to the cost of resupply and the impracticality of resupplying interplanetary missions, the prospect of growing food in flight is incredibly appealing. The existence of a space farm will aid the creation of a sustainable environment, as plants can be used to recycle wastewater, generate oxygen, continuously purify the air, and recycle feces on the space station or spaceship. A close-up view of the advanced astroculture soybean plant growth experiment in the Destiny Laboratory on the International Space Station is shown in this picture. Provision of fresh food. The ability to grow food in space will help reduce the vitamin gap in astronauts' diets and provide fresh food with improved taste and texture. Creation of sustainable environment. A mission to Mars will require food storage for a long period of time. Several proposals are being put forward on space farming. Senior flower grown inside the Fegi facility on board the International Space Station is shown in this picture. Solar cell production is another utilization of space resources. It has been proposed that solar cells could be produced from the materials present in lunar soil. Silicon, aluminium, and glass, three of the primary materials required for solar cell production, are found in high concentrations in lunar soil and can be utilized to produce solar cells. Concept of solar farm in space is shown in this picture. Solar arrays produced on the lunar surface can be used to support lunar surface operations as well as satellites of the lunar surface. Power provision to the Earth. Another potential application of lunar developed solar arrays is providing power to Earth. The proposal of solar power satellites was intended as an alternate power source for Earth. Proposed solar disk for powering the Earth from space is shown in this picture. Another utilization of space resources is found in space manufacturing. In the future, extraterrestrial materials on the Moon, Mars, and asteroids could be used for the fabrication of metal components and structures. Metals are byproducts from oxygen production from regolith. Metals can be used in the construction of electrical distribution systems on the moon, both for local use and for solar-produced electric power, which may be exported to the Earth. Demonstration of Akinor technology developed by Made in Space, which is designed for manufacturing in space, is shown in this picture. Various products can be manufactured in space using space resources. Examples of these products are semiconductors, space stations and infrastructure, large-scale manufacturing and megastructures, tools, recycling products, biological patches for earth repairs, and space food. This picture shows demonstration of autonomous in space manufacturing. Space habitat is another utilization of space resources. A space habitat, also known as space colony, space city, or orbital habitat, is an advanced form of living quarters than a space station or habitation model, in that it is intended as a permanent settlement or green habitat rather than as a simple way station or other specialized facility. Space habitat is a self-contained structure envisaged for microgravity environments of the Moon, Mars, and asteroids. This picture shows artist's depiction of a pair of O'Neill cylinders space settlements concept. It has been proposed that space resources could be used for the provision and establishment of habitat for the astronauts. Presence of space habitats and bases on the Moon and Mars will help flourishing of the space tourism industries. Some of the places on the celestial bodies that could be used as homes are caves and lava tubes on the Moon, and dwellings dug into the side of volcanic tuff headlands on Mars. This picture shows Stanford Torus, a proposed NASA design for a space habitat capable of housing 10,000 to 140,000 permanent residents. Radiation and thermal protection. Raw lunar or Martian regolith could be used as radiation and thermal shielding and protection against micrometeoroid impacts. Construction of landing pads to avoid blowing dust raised by ascent and descent rocket engines, and for thermal insulation and heat storage. This picture shows a NASA lunar base concept with a Mars driver. You've been watching and listening to Space Resources Utilization, the cornerstone of deep space exploration. Thank you.